Okay, here we go. This is a try at this, and I hope this will help you guys. What I have here is just a set of slides of the Lesson 21 practice pages, and it's just the first set. I thought if I went through this first set with you and did most of those, that hopefully you would have the idea and could go on and do the second set yourself. So these are the pages that you have there in your book, and I just am going to go through them one at a time here. Now I know the first and second one you probably, I think your mom said that you were able to get pretty well. I'm just going to use those as examples to make sure that understanding is where it needs to be. Okay, so first thing we have here is the reaction. Hydrogen gas and chlorine gas react to yield hydrogen chloride. So the first thing we have to do is to write the reaction. Okay, so we have hydrogen gas, and that's going to be one of those diatomic gases. So we're going to have hydrogen gas, H2. The and tells us to write a plus, and I'm going to write these kind of spread out in order to help me when I go to balance the reaction here in a minute. So it says and chlorine gas. So chlorine gas, again, one of those diatomic gases. So we're going to go Cl2. React to yield, draw the arrow, hydrogen chloride. So hydrogen chloride, which is going to be a compound now, and so that's a +1, and chloride's a -1, so it just takes one of each to make the stable compound. Okay, now the whole idea behind balancing reactions or balancing these chemical equations is to enable us to have a recipe then of the reaction that's useful. Okay, a useful recipe, because we can use this just like we would use a recipe for cookies or biscuits or anything like that, to know how much ingredient it takes to make a certain amount, and then if we have a certain amount on hand, to know how many we could possibly make from that. Okay, so first thing we're going to do is we're going to draw the line, and we're going to compare how much ingredient we have to how much product we have over here. Okay, and the law of conservation of matter and energy states that the amount or the number of moles of elements you put in has to equal the number of moles that you get out of a reaction on this other side over here. Okay, so what we're going to do first is we're going to list the elements on both sides, and so we've got hydrogens over here, and we have chlorines. And then I'm going to put colons after those, and then I'm going to list in the same order the elements on this side. Okay, so we have hydrogens, chlorines, so we're going to list in the same order hydrogens and chlorines, and put colons, and then we just count to see how many we have present. So the subscript here of the 2 tells me we have 2 hydrogens and we have 2 chlorines. On this side we have 1 hydrogen and 1 chlorine. Okay, so this equation as it's written is not balanced. We've got 2 parts of everything going in and only 1 part of everything coming out. So to balance it then we can use coefficients, which are large numbers we put out front of components in order to multiply or get a multiple of that component. Okay, the coefficient now only has its effect on whatever immediately succeeds the coefficient, and its effect stops when we come to a plus sign or an arrow. Okay, so if I were to put, say, a 2 right there, it would have its effect on this chlorine, but no longer any effect on anything else behind it because we came to an arrow there. Okay, so let's look at this. If we've got hydrogens, 2 hydrogens over here and 1 hydrogen over here, pardon me, it would make sense that if we put a 2 coefficient right there, that we could adjust then the number of hydrogens and chlorines here on the product side. Okay, so the 2 out front says I'm taking 2 of everything that immediately succeeds the coefficient. So instead of a 1 hydrogen, we're going to make that a 2, and then the 2 times the 1 chlorine makes that a 2 as well. And by doing that coefficient of a 2 there, you can see we're now balanced. We have 2 hydrogens, 2 hydrogens, 2 chlorines, and 2 chlorines on this side over here. Okay, so then we have a useful recipe. So we know if we put in 1 part of hydrogen gas and 1 part of chlorine gas, we'll get out 2 parts of hydrogen chloride. And the use of this will become much more apparent as we go into the next lessons which follow. Okay, let's go ahead now and let's look at the next problem there. This one says sodium and oxygen gas react to yield sodium oxide. Okay, first thing we need to do is write our reaction. Okay, so we have sodium. Now notice this is just, if it just says sodium and no other element or ion immediately following it right in there, it's just going to be elemental sodium just by itself. Okay, and means plus, so we're taking some sodium, which is sodium metal, and we're exposing it to oxygen gas, reacts to yield, so we draw the arrow, sodium oxide. So this is going to be a compound here now. Sodium oxide, sodium is a +1 charge, oxide is O -2. So to satisfy the desires of the stability there, it's going to take 2 atoms of sodium for every 1 oxide anion there. Okay, so next step is to draw the line, and we list the elements present. So we have sodium, and we have some oxygens there, and we'll put my colons, and we've got sodium and oxygens. Can we count? We've got 1 sodium, 2 oxygens, we've got 2 sodiums, 1 oxygen. Okay, you can see we're not balanced, 1 and 2 and then 2 and 1 over here. Okay, now the first thing you might be tempted to do here is fix the sodium. Okay, and to fix the sodium, it looks like if you put a coefficient of a 2 right out front here, that would fix the sodium. But now our oxygens are still out of whack here. We're still not good on oxygen. And to fix the oxygen, it looks like we need to put a 2 right there, but that's going to change our sodiums. So let's go ahead and fix this oxygen first, and then take and see what the sodium needs to have done to it. Okay, so if we look at the oxygen, we have 2 on the reactant side, only 1 on the product. So let's go ahead and put a 2 there. And you're going to find as you do these reactions are like little puzzles, and you may start in one direction and realize, oh, that won't work, and you have to reverse and come back out of that attempt and then try something else. Okay, that's what we've got going right here. So if we put a 2 out in front of the sodium oxide, that's going to give us 4 sodiums. Okay, so we're still not real good on the sodiums, but the 2 times the 1 oxygen will give us 2 oxygens there. So we fixed the oxygens. And I think it's going to be pretty easy now to fix the sodium, because we can put whatever we want out in front of this sodium. It looks like a 4 is going to do the trick for us here. Okay, so that'll become a 4 right there. So we have 4 sodiums, 2 oxygens, 2 oxygens, so we're balanced here. And then our recipe, or our reaction here, 4 sodiums for every 1 oxygen gas yields 2 sodium oxides, and that's going to be our useful reaction there, our useful recipe if we need to do this in the lab. Okay.